Now let's continue with example 2. In item 2, we're given a function phi, a scalar function phi, which is in terms of three variables, x, y, and z, is equal to x minus 1 squared plus y minus 1 squared plus z squared. And we are asked to find the gradient of phi or del phi at point 1, 0, 0. Okay, so from the formula, we know that the gradient of phi or del phi is going to give us a vector where the x component is partial phi partial x, the y component is partial phi partial y, and the z component is partial phi partial z. Okay, let's find the x component. So what we do now is we differentiate phi with respect to x by holding y and z as constant. So that will give us 2x minus 1 for the x component. For the y component, we differentiate phi with respect to y, so that will give us a 0. That term will give us a 0 as well. So we only have 2y minus 1. And for partial phi partial z, differentiate phi with respect to z, we get 2z. Okay, so now we can find the gradient of phi at point 1, 0, 0. So at point 1, 0, 0, we'll replace x with 1, so that will give us a 0. Replace y with 0, that will give us negative 2. Replace z with 0, we get 0. So this is equal to negative 2j. So that's the gradient of phi at point 1, 0, 0. Okay, now let's look at the geometrical interpretation of this. So the geometrical interpretation for del phi at point x naught, y naught is really a normal vector to the level surface. Okay, let's look at our notes here. Okay, so at point x naught, y naught, z naught, so what we do is we'll replace phi with the point x naught, y naught, z naught. We'll end up with an equation phi x, y, z equals c, where in this case c is a constant. So when you plot this function here, what we get is level surface in x, y, z space. So now the gradient of phi or del phi represent the normal vector to the level surface. W equals c. Okay, now let's look at our example again. So this is our function phi. So phi at point 1, 0, 0. So 1, 0, 0 would be our x naught, y naught, z naught. So when we replace x with 1, that will give us a 0. Y with 0, that would give us 1. Z with 0 would give us 0. So here we end up with this equation, x squared, x minus 1 squared, y minus 1 squared, plus z squared equals 1. So here we end up with an equation. Okay, so in this case our c is 1. So that equation is really a sphere where the radius of the sphere is 1 and the center of the sphere is at point 1, 1, 0. So the sphere of radius 1 centering at 1, 0, 0 would be our level surface in x, y, z space. So the gradient of phi at point x naught, y naught, z naught represent the normal vector to the level surface. Okay, let's sketch our level surface, which is really a sphere of radius 1 centering at 1, 0, 0. So if we do that, okay, let's see. So here we have the z-axis, x-axis, and y-axis. Okay, y, z, x. Okay, let's say that's a 1. And let's say this is a 1. So that's the center. So we'll go through this point and also this point. And on this side, that point and this point here. And also here. Okay, let's sketch our sphere. Let's make it red. Okay, so here we have a sphere of radius 1. Okay, and here we have a circle here. Okay, so that's a 1. That's a 1. Okay, this one is 2. Alright, so this is our level surface represented by this equation. Okay, point 1, 0, 0 would be this point on the surface. That is point 1, 0, 0. And the gradient of phi or del phi at point 1, 0, 0 is negative 2j, which is that one. So what you do is you start from point 1, 0, 0, which is on the surface, and then you move 2 units to the left because we have negative 2j there. So 2 units to the left would be 1, 2, like so. So this would be the normal vector to the surface at point 1, 0, 0. So this is the gradient of phi at point 1, 0, 0, which is equal to negative 2j. Okay, so if you want to know, well, if you look at this level surface here, if we are here on the surface, the normal vector would be pointing upwards like so. But let's see, let's calculate that. So this point is 0.111, okay? So at, excuse me, at 0.111, the gradient of phi would be, so what you do is you replace x with 1, y with 1, and z with 1 in the gradient of phi, which is this equation here. So the x component would give us 0, and then replacing y with 1, the y component also will give you 0. The z component, replacing z with 1, we get a 2. So this is equal to 2k. And yep, it is the normal vector to the level surface. When at 0.111, we get 2k, so it's pointing upwards like so. So this is the normal vector to the level surface at 0.111. Okay, again, let's recap. The gradient of phi, the gradient of a scalar, phi, the gradient of a scalar field will give you a vector. So in 2D, it represents normal vector to the level curve. In 3D, it represents normal vector to the level surface. So the gradient of a scalar will give you a vector. Okay. All right. Okay, that's it. Thank you.